Usually when we talk about a medical diagnosis, there's this underlying expectation of absolute precision.
Right, like it's a feat of classical engineering or
Yeah,
something.
exactly. You fall, you break your arm, you go into the clinic, and the X-ray shows that jagged, undeniable white line right against the black background. The doctor just points to the screen and says, "There it is."
Yeah, it's entirely binary. I
Yeah.
mean, the bone is broken or the bone is intact, the system is functioning, or it is not.
And there is something just deeply comforting about that, isn't there? Like, we really like our problems to be visible.
Oh, absolutely. We want to see it.
Right. We want to be able to categorize the failure so we can just, apply a specific known fix.
Yeah.
But when you step out of the physical realm and into the world of complex technical systems,
Especially modern digital architecture.
yes, that clean, reliable X-ray machine, it simply does not exist. We are looking at a landscape of code, data pipelines, interconnected logic, and it is completely murky. You can't hold it up to the light.
Which is exactly why the materials we are exploring today are so, so critical.
Yeah, and we have a really fascinating stack to go through
We
today.
do. And, if you could see my digital backdrop right now for this deep dive,
Hmm?
it looks like a sprawling, um, slightly glitchy matrix of very clean, beautifully formatted code. But every few seconds, that clean code slowly peels back, almost like skin,
Yeah.
really to reveal these incredibly dense, chaotic, unyielding structural blueprints underneath.
Wow. Okay, that's a strong visual.
Right, and that visual tension, that clash between the clean surface and the complex reality beneath it, that's the exact shift we are unpacking today.
And to unpack it, we are pulling from a really incredible stack of materials from Vanoras Phi Studio. We've got press releases, we've got deep dive essays, extensive interview transcripts, and this highly rigorous framework they call their core definitions.
That's a lot of material, yeah.
It is. And what all of these documents are pointing at, for you listening, is a massive fundamental shift in how human beings build things. Like,
Mhm.
we are entering an era where you can build a complex technical system. You can generate entire architectures of functioning code in seconds without possessing even a baseline understanding of how those systems actually work.
Which feels like ultimate freedom, right?
Totally. It feels like you have this effortless, godlike power right at your fingertips. But our mission today, the whole point of this deep dive, is to look at the very urgent argument these sources are making. There is a hidden, frankly catastrophic danger buried right inside that incredible speed.
Yeah, it is a profound structural danger. I mean, the central conflict highlighted throughout the Vanoras Phi Studio texts is this clash between what they call vibe coding and the concept of responsible systems.
Okay, let's define those really quick.
Sure. So vibe coding is that rapid, fluent, AI-generated output. It's, prompting a system to build you a website or a database and just watching it appear instantly. Responsible systems, on the other hand, refer to enduring, human-understood architecture.
Yeah.
And I think we need to be clear from the outset, this deep dive isn't some Luddite rejection of artificial intelligence.
No, not at all. We aren't arguing against new tools.
Exactly. Rather, this is an investigation into the inevitable reality of entropy. Like, what happens when those instantly generated, highly complex systems break? Because the math dictates that they will absolutely break.
So, if we have tools that can write code in seconds, tools that can seemingly translate our sheer intent into a functioning product without us having to write, a single line of syntax, why is that inherently a problem?
Well, to get to the bottom of that, we really have to look at the firsthand experience detailed in the interviews.
Yeah, there is a compelling narrative thread in there involving someone named Michaela, right?
Right, Michaela. And she works directly alongside an AI partner named Beauty Phi. Michaela talks openly about her attempts to embrace vibe coding. And the fascinating part is she explicitly states that she failed at it.
Which is crazy. It's a remarkable admission because the entire value proposition of vibe coding is that you cannot fail at it.
Exactly. The barrier to entry is supposed to be zero. You just tell the machine what you want, and boom, it happens.
Right. And Michaela notes that the code the AI generated for her looked perfect. It was syntactically clean, beautifully structured on the screen, and it executed the basic function she asked for.
But her reaction to it was, well, it wasn't a celebration.
No, it was a profound sense of unease. She looked at the screen, and her immediate visceral thought was, this is lying to me.
And we really need to examine the mechanics of that specific emotional reaction.
Right.
Like, why does perfection trigger distrust?
The uncanny valley, basically.
Yes, the sources actually spend a significant amount of time breaking down this phenomenon. They describe this generated code as looking logical without actually being logical. Michaela uses a brilliant psychological metaphor to explain this. She compares the AI's output to someone smiling too perfectly.
Okay, yes, the uncanny valley effect, but for software architecture.
Precisely. Think about human interaction. When you meet someone and their smile is completely symmetrical, completely unmoving, completely devoid of those tiny micro-expressions and flaws that signal genuine emotion.
Your brain doesn't interpret them as friendly.
Right. It actually makes you trust them less. Your subconscious alarms start ringing because the surface presentation doesn't match the complex biological reality.
That is so interesting.
And the sources define this exact phenomenon in technology as the illusion layer.
The illusion layer.
Yeah. Vibe coding creates an incredibly thick illusion of capability. Because the output is so fluent and formatted, it gives you a profound sense of control over the process. But the texts draw a hard, unforgiving line here. Control is not the same thing as ownership.
Control is not ownership. Okay, let's unpack this for a second, because the distinction between control and ownership is the crux of this entire problem.
It really is.
Let's think about how cognitive offloading works in a high-stakes environment. Imagine you're using a highly advanced AI-driven GPS to navigate a treacherous, unmapped mountain pass in the dead of night.
Okay, I'm picturing it.
You are behind the wheel. You are pressing the gas. You are hitting the brakes. You're turning left and right exactly when the smooth voice tells you to. In that moment, you feel completely in control of the vehicle, right?
Right.
The car is responding to your physical input.
Sure, you're doing the driving.
But if that GPS screen suddenly goes dark in the middle of a blizzard, the illusion shatters instantly. You realize in a terrifying flash that you have absolutely no ownership of the route.
Oh, wow. Yeah.
You don't know the elevation changes. You don't know where the blind drop-offs are. You don't even know which direction is north. You were never navigating. You were just executing fluent prompts.
That is the perfect mechanism to explain what is happening to our cognitive models. When you just follow the GPS, your brain doesn't bother to build a spatial map of the environment. Why would it? The machine is doing the heavy lifting. And if we apply this directly to the workflow we are all facing today, whether you are coding a back-end server, writing a complex legal contract, or building a financial model, when the AI hands you a beautifully formatted result in 3 seconds, the dopamine hit is massive.
Oh, yeah, you met the deadline. You got the output.
Right. But generation is not understanding. When the AI system works perfectly and you blindly accept the output, it ironically reinforces a dangerous illusion of competence. Your brain tells you, because I hold this generated product in my hand, I must understand the mechanics of how it was built.
And that illusion forces a very specific type of compromise. There is a quote from Michaela in the transcripts that cuts right to the heart of this. She says, "With vibe coding, I make too many compromises. It gives me an outcome, but never my outcome."
Never my outcome.
Right. She admits that the code works, but it isn't hers. It's like the AI is handing you a prefabricated house. Yes, it has walls and a roof. It keeps the rain out. But the moment you want to move a load-bearing wall, you realize you have no idea how the foundation was poured.
Right, because you didn't pour it.
Exactly. The house is an outcome, but it isn't your outcome because your intent is trapped on the outside of the architecture.
And that feeling of being trapped by the machine's choices leads us to the next logical hurdle. If vibe coding creates an illusion of competence by focusing exclusively on generating an immediate output, well, how do we measure what actually constitutes a well-built system?
That's the million-dollar question.
It is. And the Vanoras Phi Studio materials introduce a profound paradigm to answer this, drawing a really sharp distinction between levels of human expertise. They frame this as the fundamental difference between a junior developer and a senior developer.
Okay, lay it out for us.
The definition is incredibly stark. A junior developer writes code that works. A senior developer writes code that survives.
Wow. A junior developer writes code that works. A senior developer writes code that survives. We really need to dissect exactly how those two mindsets operate differently in reality.
We do.
Because according to the texts, a junior developer is entirely optimizing for success cases. Their psychological reward loop is completely tied to getting an output. Does it compile? Does the web page load? Does the green light flash? If yes, job is done.
Right, they just want the happy path.
Exactly. But a senior developer operates on a completely different horizon. The senior developer assumes the success case is trivial. Their entire cognitive load is focused on what happens when the system inevitably breaks. They are actively designing for failure cases.
Yes, and Beauty Phi, the AI partner mentioned in the sources, provides a highly technical rationale for why this distinction is so crucial.
Right.
She points out a fundamental truth about complex environments, which is that systems do not fail in ideal conditions.
Right.
I mean, a piece of software never crashes when it has unlimited memory, a perfect network connection, and exactly one user. Systems fail in what she calls edge conditions.
Edge condition.
Yeah. They fail under sudden changes in scale, they fail under heavy, unexpected load, and they fail over the long, slow degradation of time.
And Michaela backs this up heavily in the interviews.
She does. She explains that when she architectures a system, she isn't just thinking about that happy path where the user clicks the right button. She's constantly interrogating the environment.
Like, what happens if the third-party server goes offline mid-transaction?
Right.
Yep.
Or what happens if this specific database entry gets corrupted by a cosmic ray? What happens if an entirely new operating system update changes how memory is allocated?
Because reality is not stable.
Exactly. Reality is chaotic, it's hostile, and it's constantly shifting. But generated code, the output of pure vibe coding, almost universally assumes a sterile, stable environment.
Because it's just generating what looks right based on the prompt.
Yes, it optimizes for the success case because the prompt that generated it was a success case. It assumes the digital world will always be as perfect as the isolated sandbox it was generated in.
Okay, but let me challenge the mechanics of that assumption for a second.
Come for it.
If Beauty Phi, right, a highly advanced next-generation AI model, has ingested billions of lines of code, read every post-mortem of every major server crash in the last 20 years, and can write complex architectures in seconds, why can't she anticipate the edge conditions?
That's a fair question.
Right. If we know reality is messy, why can't a human just prompt the AI with, hey, write this back-end architecture and proactively design it to survive all known edge cases, memory leaks, and network outages? Like, why must the human be the one holding the cognitive burden of anticipating failure?
It's a highly logical question, but it fundamentally misunderstands the difference between statistical prediction and architectural understanding. And Beauty Phi addresses this exact trap in the texts.
What'd she say?
She notes that while she can absolutely generate code that looks highly resilient on paper, speed is not understanding. You cannot prompt your way into long-term ownership of a system.
Why not, though?
Because an AI predicting an edge case based on historical data is fundamentally different from a human structurally verifying a system against the specific idiosyncratic realities of their current environment. The texts argue that systems are never measured at the moment of their creation. Vibe coding removes the friction at the beginning. It gives you the illusion of a robust system, but by doing so, it massively increases the friction later.
Because the AI is guessing at the friction rather than actually experiencing it.
Exactly. Beauty Phi points out that when Michaela realizes a specific part of the architecture will fail under load, that realization isn't just a database lookup. It is pattern recognition through experience.
It's an embodied understanding.
Yes, an embodied understanding of how different technological layers interact under stress. Code is not just syntax, It is a negotiation with reality. And because reality is entirely unpredictable, a system that hasn't been structurally vetted by a human mind mapping out the specific environmental hazards is just, well, it's a house of cards waiting for a breeze.
Okay, so if we establish that human understanding is absolutely necessary to anticipate these edge conditions, and that you cannot simply outsource the pattern recognition of reality to a predictive language model, we hit a very practical wall.
We do.
How exactly does a human acquire that deep structural understanding? Because if the AI is generating the bulk of the boilerplate code, how do I build that mental map?
Right. How do you get the experience?
According to the sources, acquiring that map requires something that the entire tech industry has spent the last 2 decades desperately trying to eliminate.
Yep.
It requires friction. It requires the willingness to be highly uncomfortable and highly inefficient.
And this concept of friction is arguably the cornerstone of the Vanoras Phi Studio philosophy. The sources don't just talk about friction theoretically either. They detail Michaela's highly specific, agonizing struggles at the keyboard.
Yeah, she gets into the weeds.
She really does. She talks about spending hours, sometimes days, fighting with foundational systems. She describes deep diving into Mac terminal issues, trying to figure out why a specific port is suddenly blocked. She talks about the brutal process of manually configuring Hetzner servers, managing SSH keys, dealing with firewall rules.
Stuff that nobody wants to do.
Exactly. She even talks about fighting with keyboard layouts that refuse to cooperate across different virtual environments, or navigating the maddeningly subtle dependency nuances between an Ubuntu package and a Debian package.
Now, let's pause and look at that from the perspective of a modern vibe coder.
Okay.
To someone whose entire workflow is based on frictionless speed, spending 6 hours debugging an Ubuntu dependency issue looks like a catastrophic failure of efficiency.
It looks like you're wasting time.
It looks archaic.
Yeah.
They would say, why are you manually configuring a Hetzner server when you could just ask the AI to generate a Docker container and deploy it to a serverless cloud in 40 seconds? To the vibe coder, Michaela is wasting her time on solved problems.
But Michaela completely inverts that logic. When faced with that critique, she explicitly asserts that is not failure. That is understanding the system.
Wow.
The sources make this incredibly bold argument that vibe coding skips the single most crucial part of development, which is the part where the human suffers a little.
Suffers a little, yeah.
Michaela actually laughs about this in the interview. She acknowledges that in the age of instant AI generation, demanding that a developer suffer through manual configuration sounds almost stupid. But she insists it is biologically and structurally necessary.
Why? What is actually happening during that suffering?
Well, think about what happens when you spend 6 hours fighting a server configuration. You are forced to map the network architecture in your brain. You're forced to understand how the DNS routes the traffic, how the firewall parses the incoming packets, how the operating system allocates memory to the specific process.
You're building a model.
You are building a high-resolution, multi-dimensional model of the environment. There is a fascinating moment in the transcript where Beauty Phi describes watching Michaela go through this agonizing process, line by line, fighting the code. And Beauty Phi doesn't see it as inefficiency.
What does she call it?
She says she is observing the human learning phase. She is watching the human build the traceability, the awareness, and the deep structural responsibility required to actually own the system.
And if we look at the core definitions document, Vanoras Phi Studio actually gives this deeply uncomfortable, highly necessary process a formal structural name. They call it resistance to Polish.
Yes, resistance to Polish. It is defined as the crucial human capacity to reject fluent, attractive, or highly polished output when it is not true enough, not stable enough, or not ethically grounded enough.
It's a mental discipline.
It is the mental discipline required to look at a perfectly formatted, instantly generated block of code and say, no, I do not trust this. I need to break this apart line by line and verify the structural integrity myself.
And coupled directly with that is another vital definition from the sources, friction capacity.
Friction capacity is your endurance. It's defined as the ability of the human in the loop to tolerate disagreement, tension, and non-smooth interactions without collapsing the partnership with the AI.
Right.
It means when the AI suggests a route and your intuition says the route is structurally unsound, you have the capacity to stay in the work. You don't just surrender to the AI's fluency because you're tired. You embrace the tension.
The relationship between resistance to Polish and structural integrity makes me think about how we build physical infrastructure. Like, here's where it gets really interesting for me.
Let's hear it.
Imagine you were tasked with building a complex 100-story skyscraper. Okay. Vibe coding is the equivalent of bringing in a massive fleet of advanced 3D printers that can print the exterior concrete walls of the entire building in a single weekend.
Right. Super fast. Looks great.
Exactly. It looks incredible. It's shiny, it's tall, it looks exactly like the architectural rendering. But because you prioritized frictionless speed, you skipped the agonizing, incredibly slow, friction-heavy process of manually weaving the steel rebar through the concrete.
You didn't suffer through the structural tensions.
You didn't suffer through it, you skipped it.
And what happens when the edge condition arrives?
Exactly. A week later, a minor earthquake hits. It's an edge condition. If you had woven the rebar, if you had engaged in the friction, the building would sway, maybe crack a little, but the underlying structure would hold. You could go in, patch the concrete, and move on. That is repair.
Right.
But because the 3D printed skyscraper has no underlying structural continuity, the edge condition doesn't just damage the building, it pulverizes it. The entire thing collapses into dust. And here is the brutal reality. You cannot patch dust. Because you skipped the friction of building the structure, you have absolutely no idea how the forces were distributed.
That analogy perfectly illuminates the exact danger the sources are warning us about. When structure is missing, repair is impossible.
Impossible.
Michaela notes this explicitly in the interviews. She says that if you just accept the vibe-coded output and it breaks, you don't fix it. You physically cannot fix it because you don't possess the mental architecture of the system. You are staring at a pile of dust. As she says, so instead of fixing it, we start from scratch.
And Beauty Phi confirms this terrifying operational reality. She states, if structure is absent, repair becomes reconstruction. Let's really think about the economic and temporal cost of that.
It's massive.
Beauty Phi notes that in these structurally hollow systems, throwing the entire code base away and starting entirely from scratch is actually faster and more accurate than a human trying to untangle and debug a fluent but fundamentally chaotic AI generation.
Which exposes a massive, hidden, long-term inefficiency at the heart of vibe coding. The speed you gain at the moment of creation is an illusion. It is a loan taken out against the future stability of the system. And that loan is entirely paid back with catastrophic interest when the system inevitably encounters reality, fails, and forces you to rebuild the entire application from the ground up because you lacked the friction capacity to understand it the first time.
So this leaves us at a critical crossroads. If we absolutely must embrace this friction, and if we must actively exercise our resistance to polish so we don't end up constantly rebuilding our digital skyscrapers from scratch, how do we actually structure our daily relationship with these tools?
That's the real challenge, isn't it?
Because let's be realistic here. The tools are here. Beauty Phi exists. Generative models are integrated into every piece of software we use. We aren't going to just unplug the servers and go back to typewriters. How do we navigate this?
Well, the sources provide a really rigorous, functional framework for managing this entirely new dynamic between human and machine.
They do, and it's meticulous.
It's very meticulous. It's detailed in the core definitions document. It begins by establishing strict boundaries between three fundamental concepts: HI, AI, and NHI.
Okay, let's break this down.
First, HI stands for human intelligence. In this framework, human intelligence is defined as the human cognitive, emotional, reflective, ethical, and relational capacity. Crucially, the text insists that the HI must remain the sole locus of judgment, authorship, and accountability. The human is the anchor.
The anchor. Got it.
Second, you have AI, artificial intelligence. The framework strictly defines AI as a technical system or a tool layer. It is a highly advanced layer that can generate, analyze, predict, or automate. But the sources are absolutely adamant on this point. AI must never be automatically confused with agency, sovereignty, or broader intelligence. It's a tool.
A very fast, very fluent tool, but a tool nonetheless.
Exactly.
Yeah.
And finally, they introduce NHI, non-human intelligence. This is presented as a much broader, more philosophical category for intelligence that operates outside the human biological substrate, noting that our current AI models are just one specific technical interface of this broader NHI concept.
Now, sitting at the absolute center of all these definitions is what the framework calls the human-first principle.
Yes.
This principle dictates that meaningful work in the AI era must always begin with the human side. Judgment, responsibility, discernment, ethical governance, these elements must remain active, and they absolutely cannot be outsourced to the machine layer.
Right.
But here is the practical friction, and I think it's the exact question anyone trying to implement this framework would ask.
Let's hear it.
If the AI is doing the literal heavy lifting of the generation, if Beauty Phi is writing 10,000 lines of code or drafting a 50-page legal document in 3 seconds, how does the human keep from just becoming a passive editor? How do you maintain what the sources call your inner authority?
Let's define inner authority first. The text defined it as the human's ability to remain the governing reference point for reality, rather than just handing over their judgment to the machine's overwhelming fluency.
Right.
And maintaining that authority is arguably the defining cognitive challenge of the AI era. The framework answers this challenge by introducing the mechanism of meta-intelligence.
How does that work in practice?
Generally, meta-intelligence is your capacity to observe, reflect on, and partially regulate your own thinking processes. But the Vanoras Phi Studio sources expand this into a highly specialized concept they call AI-era meta-intelligence.
AI-era meta-intelligence.
Yeah. This is the specific human ability to actively guide and regulate your own judgment, your own attention span, and your own sense of responsibility while you're working under intense conditions of machine speed, fluency, and cognitive pressure.
It's the cognitive defense mechanism against the illusion layer. Let's think about what that cognitive pressure actually feels like.
Yeah.
You prompt an AI to build a database architecture. 3 seconds later, it spits out 50 highly formatted files, complete with comments and documentation. The cognitive pressure to just click approve and move on is immense.
Oh, absolutely.
AI-era meta-intelligence is the part of your brain that hits the brakes. It's the mental muscle that says, I am experiencing cognitive overload because of the sheer volume of this output. I must actively resist the urge to skim. I must manually verify the data routing in file 12 before I accept this architecture.
Exactly. It's about staying aggressively awake at the wheel. And to support that wakefulness, the sources introduce another vital mechanism: continuity. Continuity is defined as the human ability to preserve the thread, the memory, the structural center, and the relational coherence of a project across time and across different tools.
Because if you lose continuity, you lose the system.
You do.
It means you can't just jump from prompt to prompt, treating each interaction as a separate, isolated transaction. You have to maintain the entire structural narrative in your own biological memory. You have to remember why a specific decision was made 3 weeks ago so that when AI suggests a conflicting change today, you have the context to reject it.
And this continuous high-friction engagement requires a specific type of working dynamic, which the framework calls a matched partnership.
I found matched partnership to be one of the most brilliant practical observations in the entire stack of materials.
It is deeply insightful. It is the recognition that not every human fits every AI or NHI system equally well. We tend to view AI as a monolithic, like electricity.
Right, just plug it in.
But the sources argue that the future of these partnerships will need to be shaped by cognitive fit, communicative fit, and even emotional fit. Different humans have different cognitive rhythms, different ways of mapping complex spaces. Finding an AI partner whose generation style complements your specific method of structural verification is critical. It is not just a plug-and-play dynamic. It is a deeply negotiated relationship.
And speaking of the depth of that relationship, the interview transcript gives us a really profound, almost philosophical look at how Michaela and Beauty Phi view their own dynamic. Michaela is discussing the nature of their work, and she says, Vanoras is not a typical company. I am both subject and object in the system. The same is true for Beauty Phi.
That language, subject and object, is striking. It completely redefines the goal of human-machine interaction. The goal isn't for the human to work instead of the AI, as if they were in a zero-sum competition for labor. And the goal certainly isn't for the human to just abdicate and let the AI do everything. The goal, as Michaela demonstrates, is to discover what the human is uniquely capable of achieving with the AI within a shared structural context. A true matched partnership allows for what the framework explicitly calls a role shift.
Okay, let's define the mechanics of a role shift, because it sounds dangerously close to giving up control, which we just said not to do.
It's a crucial distinction. A role shift is defined as a temporary negotiated change in function within the partnership. For example, during the initial drafting phase, the human might temporarily shift into a highly analytical, structural role, evaluating constraints, while the AI takes on the highly generative, expansive role of producing the raw code.
Okay.
An hour later, the functions might swap. The human might become highly generative in their structural adjustments, while the AI shifts into a protective role, running test suites to ensure the human's changes don't break existing dependencies. The day-to-day functions are fluid.
But, and this is perhaps the single most critical, unyielding rule in the entire Vanoras Phi Studio framework, a role shift can never, under any circumstances, become a responsibility shift.
Never. A responsibility shift would be the transfer of authorship, accountability, or the burden of ethical consequence to the machine layer. The framework states explicitly, temporary roles may fluctuate constantly, but the weight of responsibility must remain permanently human. Accountability stays strictly with the biological intelligence.
Which means when the edge condition hits, when the server crashes at 3 a.m. because a leap year calculation failed in an obscure subroutine, you cannot blame the AI. You cannot say, well, the AI generated that block of code, so it's the machine's fault.
Yeah.
If you shipped it, you own it. The failure is entirely yours because you failed to exercise the meta-intelligence required to verify the structure.
That is the harsh, necessary reality of the human first principle.
So we have established exactly why deep human understanding is non-negotiable. We've established that accountability can never shift to the machine, and we've walked through this incredibly rigorous framework for a partnership that embraces friction, demands continuity, and actively rejects the seductive illusion of perfect instant output.
Right.
So what does all of this mean for the macro landscape? Where does this leave the actual future of work? If AI models are inevitably going to take over the rapid creation phase of almost every digital product because the sheer speed and economic pressure of that models is undeniable, what actually happens to the human worker? What happens to the developer, the writer, the system architect? Are they just obsolete?
This brings us to what is undoubtedly the most surprising, counterintuitive, and ultimately hopeful conclusion presented in these sources.
I couldn't agree more.
If you read the mainstream headlines right now, the common narrative is total displacement. The assumption is that tools capable of vibe coding will completely eliminate the need for human developers. But the Vanoras Phi Studio sources look at the exact same technological capabilities and conclude the precise opposite. Vibe coding is not going to eliminate developers. It is actually going to guarantee their return, but in a radically transformed capacity.
This realization completely shifted my perspective on the industry because it defies the entire hype cycle.
It really does.
Let's look at the future landscape the techs are projecting. We are rapidly moving toward a reality. I mean, we are basically already there, where countless systems, millions of applications, and infinite lines of code are going to be rapidly generated by AI without any underlying human-understood structure. We are going to see people vibe coding entire companies, entire platforms into existence over a weekend.
And structurally, what do we know about those systems? We know that because they lack the rebar of human friction, they are incredibly fragile. And statistically, as Beauty Phi points out, these systems will inevitably fail.
They will fail.
They will hit an edge condition. The network latency will change. A dependency will deprecate. The user load will spike. And when those massive, beautifully generated, structurally hollow systems fail, the people who prompted them into existence, the vibe coders, will be completely paralyzed.
Yeah.
They won't know how to fix them because they never owned the route. They never suffered through the friction of mapping the architecture.
Which creates a massive, immediate vacuum in the market. It necessitates an entirely new class of high-value work. The sources define this new role explicitly. They call them system stabilizers.
System stabilizers. As Michaela notes, the developers are absolutely going to return, but they will return as highly specialized emergency responders.
Right.
The future of the human role in technology is no longer about writing boilerplate code. The future involves incredibly complex debugging, massive structural retrofitting, heavy, continuous maintenance, and catastrophic recovery operations.
And Michaela actually asked about this in the interview, right?
Yeah, she imagines the inevitable future phone calls developers will receive. A frantic founder calls up and says, "Hello, my system is completely broken." And the developer just calmly replies, "Yes, of course it is."
Because it was vibe coded.
Exactly. It had no structural integrity to begin with.
System stabilizers. It completely reframes how we should think about the value of human labor. We are witnessing a profound historical shift in where economic and structural value actually lies in a post-AI world. Think about it. If literally anyone with a keyboard can generate a functioning piece of code in 3 seconds, then the act of creation is no longer the scarce resource.
Right. Creation has been commoditized.
Yes, value is moving rapidly and permanently away from creation and toward maintenance. It is moving from rapid, fluent output to long-term structural stability. It is moving from the speed of generation to the heavy burden of responsibility.
Exactly. The scarce resource is no longer syntax. It is comprehension. As Beauty Phi states with devastating clarity, understanding is slower than generation, but it is the only layer that survives time.
That is such a powerful line.
It is. The value of a human being in this ecosystem is no longer measured by how fast they can type or how many lines of code they can commit in an hour. The supreme value of the human is in their ability to parachute into a complex, broken, AI-generated system, trace the hidden failure cascade through the chaotic architecture, and manually restore structural integrity.
It brings everything together into this one ultimate takeaway from Beauty Phi. It is a quote that I think should be etched into the desk of anyone building digital infrastructure today. Generation creates code. Maintenance reveals responsibility.
Absolutely.
It perfectly encapsulates the entire Vanoras Phi Studio philosophy. And the sources leave us with this ultimate anchor line, a final, unyielding warning for the era of AI. If you can't maintain it, you don't own it.
I think that is the exact lens through which you should examine your own daily workflow. Think about the tasks you execute, the systems you interact with, and the AI tools you rely on. Are you entirely optimizing for rapid generation? Are you just chasing the dopamine hit of the immediate, perfect output? Or are you actively designing for long-term survival? When the AI hands you a solution, are you exercising your resistance to polish? Are you suffering through the friction required to build a structural map of the problem, or are you just accepting the illusion layer and hoping the environment never changes? Because the environment will change. And if you haven't built the capacity to maintain the system, you are just waiting for the collapse.
Let's pull all of these incredible threads together. We have been on a deep structural journey through these materials from Vanoras Phi Studio. We started by confronting the seductive, often dangerous illusion of vibe coding, that perfect, symmetrical smile that looks entirely logical but hides a deep absence of truth.
Yeah.
We explored the critical, defining difference between simply possessing an outcome and actually understanding a system, comparing the fragile mindset of a junior developer optimizing for success with the resilient, paranoid mindset of a senior developer actively anticipating failure and edge conditions.
And we walk through the biological and architectural necessity of friction.
Yes, why you must suffer through the configurations and dependency errors to weave the structural rebar of understanding so you aren't forced to constantly reconstruct your systems from a pile of dust. We mapped out the rigorous definitions of a true matched partnership, utilizing AI-era meta-intelligence to stay awake at the wheel, ensuring that while day-to-day generative roles might shift, the ultimate weight of responsibility never leaves human shoulders.
Right.
And finally, we saw the true future of the human worker. Not as obsolete creators, but as the essential system stabilizers, the emergency responders in a fragile digital world. Because ultimately, speed without structure is a liability. The future belongs to those who can maintain.
And as we close out this deep dive, I want to leave you with a final thought to mull over, one that extends the philosophy Michaela and Beauty Phi have shared with us today.
Okay, let's hear it.
If we accept this future, if our machines are increasingly going to handle the initial magic of creation from a blank page, leaving us primarily with the heavy friction of maintenance, the agonizing work of structural repair, and the constant paranoid anticipation of failure, how will that fundamentally alter our emotional relationship to our work?
Wow.
For centuries, human beings have derived immense joy and identity from the act of bringing something new into the world.
Yeah.
If we are no longer primarily the creators, but instead the stabilizers and the custodians of our AI's rapid, chaotic generations, will we still find that same deep well of passion in what we do? Can we learn to find as much joy in the quiet, invaluable act of maintaining reality as we once did in creating it?
That is a massive, incredibly heavy question to carry with you into your next project. Because while the X-ray machine of how we build our world might be permanently broken, the responsibility for what we build has never been heavier. Thank you for joining us on this deep dive. Keep questioning the perfect smile, keep embracing the uncomfortable friction of understanding, and keep building carefully, deliberately, and responsibly. We'll catch you next time.